And hello, welcome back. This is another little video I'm putting together. This is a video on coordinate proof, okay? And in this video, I'm going to walk through a couple things. One, I'm going to talk about the chart that we put together in class. This was investigated in class, varying numbers. You can find this on the Binder website, the Will Not Fail Binder website for your class. We did a little investigation during which we discovered varying properties of these four types of quadrilaterals, the parallelogram, the rectangle, the rhombus, and the square. And in this video, what I'm going to talk about is, not only am I going to rehash the properties, but I'm also going to give three examples, one that I'm going to try, one we'll do together, and one I'll ask you to try about coordinate proof. And through that, hopefully we'll get a sense of what I'm looking for when I'm asking you to do this. Because in looking at some of the assessments and some of what you're doing in class, what I'm seeing is statements like these sides are parallel, these sides are congruent, but what I'm not seeing is the work that backs that up, okay? And so I'm going to be putting most of the emphasis point-wise and feedback-wise on the work that you're doing, because anyone can claim something. It's another thing to actually justify that that is true, okay? So here we go. I'm going to start by recapping these properties. So what we know is that the sum of the angles is 360. That's true for any quadrilateral. And in fact, in terms of any parallelograms, the first 5 statements are true across the board, okay? Every one of these 4 shapes has these properties, okay? There's nothing unique about them in terms of the 4 shapes you see here. So all 4 shapes, sum of the angles is 360, opposite sides are parallel, consecutive angles are supplementary, meaning they add to 180. Opposite sides are congruent, or rather opposite angles are congruent, opposite sides are congruent, and the diagonals bisect each other. If we're going to do coordinate proof, we can show this by showing that there's parallel means same slope. We can show this fairly easily, congruent, by showing distance. The rest of these are relatively difficult to show. And so in coordinate proof, right, it's hard to calculate the angles if I've only given you the coordinates. We don't necessarily have any means to do that yet, okay? And so hopefully I believe I asked us to do this, but if not, what I'm going to do is I'm going to draw a line right here. And why I'm drawing this line is because every one of these shapes is true above the line, right? Checks all across the board, okay? And what that means is that rectangles, rhombuses, and squares are all essentially parallelograms, okay? But if we go below, but we know the parallelogram, the sides do not need to be congruent, the angles are not congruent, the diagonals are not congruent. The diagonals are not perpendicular, right? This is what perpendicular diagonals look like. They meet and you got a nice 90 degree, not true. And the diagonals do not bisect the angles. Okay? But if we talk a rectangle, not true, sides are not congruent. But here's where it gets interesting. So a rectangle below the line, everywhere a rectangle is false, a rhombus is true. For example, rectangle, all sides not congruent, but actually with a rhombus they are. The angles are all congruent with a rectangle, but they're not with a rhombus. The diagonals are actually congruent due to the Pythagorean theorem is one way to show it, but not true with a rhombus. The diagonals are perpendicular. That's actually not true with the rectangle, but is true with a rhombus. And the diagonals do not bisect the angles of a rectangle, but they do in the event of a rhombus. So if we're thinking about coordinate proof, what we need to do is at the very minimum, we need to show opposite sides parallel, opposite sides congruent. That establishes that we have a parallelogram, okay? But we now need to look at this feature right here, all sides congruent. So if I can show opposite sides parallel, opposite sides congruent, all sides congruent, that means I must have a rhombus. It couldn't possibly be a rectangle, because if it were a rectangle, this wouldn't be true, okay? Now, on the other hand, if I believe that I have a rectangle, I need to be able to show that all angles are congruent. because if I can show that all angles are congruent, well, that is true of a rectangle, but not a rhombus, okay? So these are things I can show. You alternatively could show that the diagonals are congruent. I'm going to put a star there and in different colors. It would work for a rectangle, and you can do that because you can see, for example, you could also do this. This is optional. So you could show this or this. So you could either show sides congruent or diagonals perpendicular if you want to show it's a rhombus. I think the sides congruent is easier because you have to show the opposite sides are congruent anyway, and you need to calculate the sides anyway. And so while you're doing that, you might as well just show all sides are congruent, okay? So there are things that are optional and there are things that are not, but you have to show these two for sure and one of these. And then if I'm asking you to show a square, well, squares are actually really cool because everything is true about a square. Okay, so with a square, you need to show all angles are congruent to rule out that rules out a rectangle. You need to show that all angles are congruent, and if you can do that, if you can show that not only are all sides congruent, but all angles are also congruent, then that makes sure that it's a square, because the only shape with both of these properties is a square, okay? So again, for a parallelogram, to show it's a parallelogram, at the very minimum, you need to show this, that all opposite sides are parallel and opposite sides are congruent. That is the minimum to establish a parallelogram, okay? For a rectangle, you need to show that all sides, opposite sides are parallel, opposite sides are congruent, and all angles are congruent. Okay? For a rhombus, you need to show that opposite sides are parallel, opposite sides are congruent, and all sides are congruent. And remember in class, what I said was, I said if you start by showing all sides are congruent, and you can show me that, then it's reasonable to conclude that opposite sides will also be congruent. And then finally, for a square, you need to show me opposite sides, and let me get my blue ink. Opposite sides are parallel, opposite sides are congruent, all sides are congruent, and all angles are 90, okay? So this is an overview, and I would recommend that either throughout this video when you're struggling, well, first of all, best case, use the sheet that I've given you guys. I gave you the sheet. I told you this is going to be the #1 most significant sheet in this unit. You have to use your notes. It's an important skill. You need to go back, check and make sure you have this, check and make sure you have the checks where I do. Remember, all above this line is all checks. All of these should be checked. These all checked, etc. Okay? Have that with you. If not, please take a picture of this so you have access to this, okay? It's extremely important that you do that, all right? I'm trying to help you here, but I can only help you. If you help yourself, you got to help me too, okay? So again, look through your binder, make sure you have this, and that will provide a big time help for you, okay? It will be a numbered worksheet for sure, okay? For CP, I believe it's 213, and I don't quite remember what it is for honors, but again, check the binder website. It will be there, okay? All right, so again, I encourage you to go back to this and to take a look at this because this is going to be helpful as we do the video. Feel free to rewind, and I will put timestamps down below. So if you need to skip back to this, you can do that, okay? So what I'm going to do is I'm going to start talking about the first coordinate proof that we have here. So it says, determine what type of quadrilateral ABCD is if A is -1, 3, B is 1, 6, C is 7, 6, and D is 5, 3. Remember, there's two types of questions. Question type 1, prove that it is a blank. If I say prove that it is a blank, I'm saying it is it. Now show me. Here, I've given you the harder problem because I think that if you can show it with the harder problem, you can do it with the easier problem. This says, determine what type it is. Okay? I'm not telling you specifically, but I'm asking you to show me. So the first thing you always want to do, especially when you're given points in an empty graph, and I'm going to do this in blue, is you want to graph the points. Okay, so here's A. 1, 2, 3, 4, 5, 6. 1, 6. 7. 1, 2, 3, 4, 5, 6. And 5. 1, 2, 3, 4, 5. 1, 2, 3. Okay, so here's B, C, D. Okay, let's connect them. Okay. All right. Now, it looks like a parallelogram, but remember that figures are not drawn to scale, so you cannot assume that it is anything. Okay, so please keep that in mind. So, now we need to work through this. So what we need to do is we need to calculate all the slopes and all the distances. So I'm going to start by finding the slope of AB, and the rise is 3, and the run is 2. Okay, so I'm going to come over here. M, the slope of AB, is equal to the rise over the run. Okay, let's look at BC. Well, we know, and I'm going to just move this so I can fit it all in here. We know that the slope of BC, look, this is a flat line. So there is no rise over a run of 1, 2, 3, 4, 5, 6. Okay. The slope of CD. Now make sure you're always going left to right. So we're going, again, make your nice slope triangle. Make it a little bit nicer than I've been making it. Remember, I'm still getting the hang of how to use this stylus here. So 3 and 2. Okay, so it's up 3 over 2. And the measurement, the slope rather, of AD is up 0 over 6, which is 0. So this is required. You need to show me the slopes. Now that you've shown me the slopes, you can make conclusions about those slopes. And that's what we'll do in a minute. Now what I want to know is I want to know the distances. Okay? So the distance from A to B. And you really should put these lines over to indicate that they're line segments. This is like measurement. Is equal to, we need to use the Pythagorean theorem. So notice, this is a right triangle. Okay? And so I need to do this. So remember, in a right triangle, A squared plus B squared equals C squared. And this is the C. What we don't know is called the C. And this is A. One of them is A and the other one is B. So it goes back. And why can we do that? Because we're in a rectangular coordinate grid. And that allows us to ensure that we have nice right angles. Okay? So let's do it out. We have 9 plus 4 square root of 13. Now, it doesn't matter what it is necessarily. What we care is how it compares. Okay? Now, BC has a 0 slope, so we can go ahead and just count across. And we know that's going to be 6. You can count it, or we can see from the slope. The measure of CD is going to be, in this case, 2 squared plus 3 squared. It's going to be 13, square root of 13. And measurement of AD is 6. Now, let's take a look at the slopes. These are equal. These are equal. These are not opposite reciprocals. So that means that these are not parallel to each other, or rather perpendicular to each other. So these are not 90-degree angles. The fact that the distances are not all equal means it's not a rhombus. Okay, and the fact that these are not perpendicular means it is not a rectangle. Okay, so what do we conclude? First of all, so we say opposite sides are congruent. Okay? And I want you to explain why. Why are the opposite sides congruent? Okay, because they've got the same length. Okay, if you said distance, that's also okay. Okay, what else do we know? Opposite sides are parallel. I know that because they've got the same slope. Okay? And again, if you claim that, I can come and look. Yep. Okay, A, B, C, D. Yep, you got the slope. Okay, I can confirm that. Work looks like it agrees. Okay? And so, therefore, it is a parallelogram. So if I ask you to show it's a parallelogram, you're good. If I was going to be technical, I could say it's not a rhombus. Why? Well, we can see from the lengths that measurement of BC is not equal to measurement of CD. You just choose two that are not the same, right? Because to be a rhombus is to say all sides are congruent. If you can show two sides are congruent, then not all sides are congruent. So you're done. So remember, it's like I said in class, it's easier to prove not than is. And it's not a rectangle because there's no opposite reciprocal slopes. Okay, and if you claim that, I can look and see. And we can actually say it's not a square either for that reason. So what we know is it is strictly a parallelogram. Okay, so to recap, whenever you get a shape, if it's not plotted, you plot it. Step one. Let me just do this in a different color. Step one, plot it. Step two, draw any slope triangles to get the slope. Remember, you do not, I would recommend that you can consider simplifying the slope, but do it at your own caution, because notice that if you do the slope first, these two numbers are directly used when calculating the distance. So if you think about it, if you simplify it, are not going to get the correct number. And okay, I would argue that if the two numbers are different, like even if you have, I use this example in class. Say you had 10 over 3 and 20 over 6. These are equal. So if these were your triangles, they would be parallel. But by not simplifying, you can see that they've got different lengths because this numbers are each twice as large as those numbers, so the lengths aren't going to be the same. So that would actually show it is not a parallelogram, though these are parallel. Maybe it's a trapezoid or something like that, okay? So remember, keep it on simplified. I'm okay with that if you leave it on simplified. If you're watching this video and you don't have me as your teacher, I recommend asking your teacher for clarity on that, okay? So I really recommend you go back if you need to, pause the video, and work through this, and then in a moment we're going to try one for you to try, or actually for us to try. All right, here we go. Here's what we do. So determine what type of quadrilateral ABCD is if these four are true. So first what we're going to do is plot the points. -4, -1, 0, 3. Wow. 1, 2, 3, 4, 5, 6, 7, 8. 5 and 5. Just want to make sure I got all my points right. All right. What I'm going to do is this. I'm going to mix this up. I'm going to do, let's see, 1, 2, 3, 4, 5, 6, 8. I think I was thinking I forgot to make. So what I'm going to do is this. I'm going to do 2, 3, 4. 1, 2. 1, 2, 3, 4. Here we go. So this is me changing stuff up on the fly. This didn't really work. I think I meant I needed to switch something and I didn't. So what I'm going to do is I'm going to, sorry about that, switch this number up real quick. And I'm going to make it 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So I got -4, -1, 0, 3, 8, -1, 2, 3, 4, 5. And there I go. Okay, hopefully this works out. Okay, and actually turning your pad is not helpful. I recommend you have some graph paper for this. Alrighty then, so here we go, and what we need to do is we need to make some proofs around this. Okay, so what I'd like to do is I need to figure out where do we go from here. So take a second and think about it. What do we need to start by doing? What was the next step after we plot the points? And let me just label them A, B, C, D. Remember, what was the next thing we do once we have the points? We make our triangles. We make our slope triangles, because remember, the slope triangles are going to help us do two things. One, they're going to help us calculate the slope, and two, they're going to help us calculate the distance. And we cannot do anything with a coordinate proof unless we do those two things. All right, here we go. Alrighty, so here we go. Let's see what kind of shape we have. Wait, we might not have anything if I mess it up. Let's see. This is supposed to be a quadrilateral. So let's take a look. We have 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay? Down here. Now, you always go, remember, left to right. So this one I'm going down from left to right. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay? The green, down. I'm going down. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, black. I'm going over, up. 1, 2, 3, 4. I'm going over. 1, 2, 3, 4. Okay? All right, so let's do out our 4. Let's start with our slopes. So I'm going to do an analysis. Remember, we do our slope. So M, slope. Okay, what is it? It is what over what? 4 over 4. Distance. Four squared plus 4 squared. That's 16 plus 16, which is 32, which is 4 square root of 2, because it's 16 times 2. Don't worry if you struggle with simplifying that. We will have some more practice with that during the year. Okay, and I'll keep you up to date on that. Okay, now I'm going to do BC. So remember, think about what we think this is. It looks like a what? It looks to me like a rectangle. So think about what we need to show here. Okay, and if you're stuck at this point, you don't know, rewind the video back to that chart that I spent a few minutes working on there. Okay, so now distance equals -8 squared plus 8 squared equals 64 plus 64, which is 128, which is 8 square root of 2. Okay? So it's actually double as long as that. Okay? Next one we need to do is CD. So, and I should just clarify, this is the M. So the M is 4 over 4, and the distance is 4 squared plus 4 squared, okay, which is, and remember, this squared plus that squared, which is 32, which is 4 root of 2. And last, we have magenta, and that is AD, and the M is negative 8 over 8. Okay, and the distance is negative 8 squared plus 8 squared, which is 64 plus 64, which is 128, which is 8 square root of 2. Okay, so let's take a look. Notice, same length, same length, same slope, same slope. Now, simplifying actually show, if you look at this, 1, 1, negative 1, negative 1. And those are opposite reciprocals, okay? So, here we're going to write our conclusions. So, we know opposite sides are congruent, same slope. And you're allowed to say that because there's clear work showing the slopes are the same. Now you have opposite sides are parallel, same length. You could say length or distance. And again, there's work to show that. And adjacent sides are perpendicular. So all angles 90 degrees. And why do you say that? Because of opposite reciprocal slopes. Okay? Now, if I'm grading you and you say this, I come and look. So you claim same slopes, opposite sides. Okay, I can see that. Nice. And sorry, I didn't mean to say slope. These actually are reversed. These reasonings are reversed. So opposite sides are parallel. I'll make this a little bit easy. I'll make this a little bit easier instead of flipping that around. So this is actually reversed. So same slope means that opposite sides are parallel, and same length means that opposite sides are congruent. So in any case, you say opposite sides parallel, you claim the slopes are the same. I come and look, okay. You say opposite sides are congruent, same length and distance. I look at the distance. You're clearly labeled as D for distance. Okay, I can see those are the same. Adjacent sides perpendicular. All angles are 90 because of opposite reciprocal slopes. I can see you've simplified them. Perfect. Okay, so you have your evidence, and then your conclusion is, and this just means, these dots just mean therefore. Therefore, shape is a rectangle. Okay? And if you want to, you could say it's not a square. All sides not equal. Okay, that's a fair claim. And you've shown that. I would say the burden of proof is less on you when it's a not, and after you've already established what is. It's not a rhombus because for the same reason. All sides would have to be equal to be a rhombus. Okay, so again, hopefully you found it to be educational. Hopefully you found that helped you. I'm going to go ahead and ask you to rewind if needed and make sure you understand everything. And then in a moment, I will go ahead and move on. All right, on to the last problem. This is a you try. So what we're going to do is we're going to take a moment. Okay, I'm going to start with the 4 points. I've got 2, 1. I've got 5, 7. I've got 11, 4. I've got 8, negative 2. Okay, 2, 1. 11, 4. Okay, 8, negative 2. And 5, 7. So go ahead, pause the video, see if you can figure out what quadrilateral it is with the coordinate proof. Is it one at all? Is it any shape at all? That is possible. It could be a trick. It might not be any kind. It might not be any kind that we've seen. But please go ahead, pause the video, try to show which one it is, and then in a moment unpause, and I'll show you how we do this problem. All right, here we go. So step 1, let's go ahead. I'm going to just really go a lot faster through this. Let's put our points up. 2, 1. 11, 4 is over here. That's actually C. 5, 1, 2, 3, 4, 5. 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. And 8, negative 2. So to me, it looks a lot like this guy's going to be a square. Okay? But I need to do some proof here. Okay, I got to prove it. Okay, looks like a square. So again, we're going to do our slope triangles. Feel free to use different colors on a quiz or a test. You're totally welcome to do that. All right, here we go. So from A to B, and we can use the coordinates as a guide. I know that I am going over by 3, and I'm going up. See, over by 3, up by 6. Over by 3, up by 6. Okay, here I'm going down by 3. 1, 2, 3, 4, 5, over by 6. Here I'm going down 1, 2, 3. Over by 1, 2, 3, 4, 5, 6. Here I'm going over by 3 and up by 6. Okay, so first I'm gonna do my slopes. Here's another way you can organize it. 1, you have your slopes. So you have AB is 6 over 3. BC is negative 3 over 6. CD is 6 over 3, and AD is negative 3 over 6. Now, if you do it like this, what you can say based on the slopes, opposite sides are parallel, same, and notice adjacent side, flip, and opposites. This is the opposite reciprocal. So adjacent sides perpendicular, opposite reciprocal. Okay? So you've already proven that. Now I need to show lengths. So AB is the square root, and you need to be very rigorous here. 6 squared plus 3 squared. So that's 36 plus 9. So that's 45. which is 3 square root 5, because this is 9 and 5. Okay? Now BC. Okay? Notice negative 3 is 9. 3 squared is 9, rather. Remember, negative 3 squared is not the same thing as negative 3 squared. Negative 3 squared means negative 9, because you square and then negative. That's not what I want. What I want is to multiply negative 3 by itself, not to take the opposite of 3 squared. Okay, and this again is square root of 45, which is 3 root 5. Okay, next one I've got CD. Okay, and CD is obviously going to be 6 squared plus 3 squared. So you can just go right to, that's root 45 or 3 root 5, because we've already done this up here. And then lastly, AD, well, that's not going to be any different than BC, because you're literally squaring the exact same thing. And remember, the order of addition doesn't matter, so you could really do that however you want. Okay. So all lengths are equal, so all sides are congruent. Okay? And I can see the work, so you're allowed to say that. So again, what have we done? Calculated, got the points, did the slope triangles, calculated all 4 slopes, said that based on the slopes, the opposite sides are parallel because the slopes are the same for the opposite sides, adjacent sides perpendicular because they're opposite reciprocals. I look, I see the work, checks for me. Then we come down, we do the lengths. So we say all lengths equal, so all sides congruent, and I can see that. Okay, so the work is justified. Okay, or the claim is justified. So therefore, all sides congruent, and we've already claimed that with work. Opposite sides parallel. Adjacent sides perpendicular. The shape is a square. Okay? You've now proven the shape is a square. Okay? So look, folks, this coordinate proof comes down to these key rules and properties of shapes. We need to know these because this chart I stress the importance of because it demonstrates how each shape relates to the others. So you need to have an understanding, one, of the properties of the 4 shapes and also how they relate to each other, okay? So I hope you found this video to be informational. I hope you really took the time to go through and understand it. It's something I always appreciate you doing. Keep at it, right? Keep sending me questions. Don't give up. Never give up. And remember, you can do it. All right, folks, thanks for watching. Have a wonderful day. And don't forget to love math. You can do it.